In this presentation, we will, we will discuss the path to creating, delivering, and assuring services using the DIME computing model. It exploits the parallelism and high bandwidth available in the new generation of microprocessors. The DIME computing model itself is described in my book, Designing a New Class of Distributed Systems, published by Springer. In this presentation, we will focus the application to develop a DIME network-aware Linux, Apache, MySQL, Perl, PHP, Python cloud. I will describe now how we have used process virtualization to create a network of DIMEs implementing Linux, Apache, MySQL, and PHP-based web service with auto-scaling, self-repair, and end-to-end transaction FCAPS management without using hypervisor or other resource virtualization and management frameworks. We transform the Turing machine implementing von Neumann computing into a distributed intelligent managed element which implements the non-von Neumann managed Turing machine. The control network is an overlay over the current von Neumann serial computing network. Each Linux process is then controlled by the FCAPS management, and essentially we convert every Linux process into a managed computing element that provides fault configuration, accounting, performance, and security management. The control network allows to set up the various parameters that are required for executing the process, and it can start by loading and executing the process executable. The control network also allows you to stop the computing machine at any time you desire based on policies, and you can also restart, for example. So this picture shows a simple service being controlled, loaded, and executed. There are three benefits derived from the DIME network architecture. One, it provides fault configuration, accounting, performance, and security, visibility, and control at Linux process level, eliminating the need for virtual machines, hypervisors, and the associated management complexity. Number two, it decouples the services management from infrastructure hardware management. And number three, the signaling control network allows end-to-end distributed transaction FCAPS management, both in the intercloud and intra-cloud environments. This picture shows the screenshot of how to create a DIME-aware Apache application and DIME network-aware PHP modules. This picture shows the drag and drop screen for creating a DIME network where multiple Apache applications are configured as primary and the secondary servers, and also a DNS which assigns the primary and the secondary list to create a computing cloud of Linux and Apache servers. Each component is encapsulated as a DIME, and the application or service running in the mice is controlled by the FCAPS manager. The fault and performance information from each DIME is collected through the signaling channel and is utilized by the end-to-end DIME network management infrastructure implemented here in the administration panel. The policies are implemented by the DIME network configuration manager, including the supervisor, fault manager, performance manager, accounting manager, and the security manager functions designed to execute policy implementation workflows. The DNS provides the primary and the secondary list of the Apaches encapsulated in different DIMEs with different addresses. When the primary DIME fails, the secondary is replaced, and also automatically the DNS is updated to show the new configuration. The performance information is monitored from the Apache web server and is used to scale additional Apache servers and update the appropriate DNS entries so that the load balancing is accomplished as you scale up or down. This video shows creating a DIME-aware Apache and DNS network with load balancing and auto failover using DIME network management. The IP addresses and configurations are provided to configure and execute a DIME-aware LAMP network. The XML file generated by the GUI program is shown here, which lists the primary Apache, the secondary and tertiary Apaches, along with the DNS server addresses. Here we see the fault manager and the configuration manager in action, providing the information to the DNS about the primary and the secondary and tertiary Apache configurations. This video shows multiple users using a particular service which is showing a counter. The service application here is a PHP application which reads from a MySQL database, increments it by 1 and writes back the counter. As you can see here, the center one is showing the user logging in with the security credentials, and the two counters on left and right are showing two users using the service. Next, we show the auto failover from one Apache server to another Apache server when we go and kill one of the Apache servers that is providing the service. As you can see, the IP address changes when the failover occurs, but the service is uninterrupted and the counter keeps on counting. DIME network aware Apache is implemented using no hypervisors or virtual machines. It also can be implemented either on a local IP address or a cloud IP address without using the cloud service provider management services. This picture shows the performance characteristic, which is the response time as a function of the request. As you can see, as the performance degrades, we can add additional dimes and control the response time. This picture shows that we can dramatically increase the performance by improving the response time as a function of the number of requests by adding 2 dimes instead of 1 dime. It is interesting to look back at what von Neumann said in his Hickson Symposium in 1948. It's very likely that on the basis of philosophy that every error has to be caught, explained, and corrected, a system of the complexity of the living organism would not run even for a millisecond. We believe that the dime computing model, by introducing the managed Turing machines, brings the cellular architectural resiliency to computing infrastructure. I have 2 video links here which show the parallax operating system and also dimes in Linux approach. Thank you. This table shows the comparison between conventional computing, cloud computing, and dime computing. In the case of conventional computing, the physical server is the base computing unit, whereas in a virtual cloud computing environment, virtual server becomes a base computing element. In dime computing, in the process-based virtualization in Linux, a process itself is a base computing unit, and in parallax, a core becomes a computing element. Now, we have listed here various characteristics and the differences between the 3 computing models. As you can see in the last row, the management latency is different in different computing models. The dime computing model essentially provides real-time management where the service transaction time and the service management latency are approximately equal. This picture shows the evolution of pots, pans, and distributed computing. Obviously, the AT&T Bell Labs contribution to the first cloud, which was the voice cloud, was to connect billions of users using plain old telephone service POTS. With the introduction of the internet, billions of devices were connected and provided a platform for pretty amazing new services, the PANs. Now we have a new opportunity with the distributed clouds where the server is a cloud and a federation of clouds will provide connecting services to trillions of managed and distributed services. Thank you.